Okay, so welcome again to this free live training session of Ask Alex. Today's topic is modeling approaches labs in OpenBridge Design. So let's do this, right? So I have already, to save some time, OpenBridge Designer, OpenBridge Modeler open right here, right? And let's start with the OpenBridge Modeler workflow. And just for the ones that join us, not in that series of videos that we're doing, just gonna create very quick a bridge, right? So let's create a bridge with the bridge wizard, right? And I already have referenced the alignment, the terrain for that bridge. So very quick, I just select the alignment that is going to be, oops, sorry, I didn't got into the wizard. So let's pick an alignment from here. That's that. Oh, selection, sorry. So one more time. And this is the key of doing this live. All right, so now I finally pick it, right? So select it here. This is where the alignment is going to start. Again, nothing special, just selecting the bridge and just going for it, right? We have covered, sorry, in previous sessions, how to go into the wizard, right? So I just wanted to create a bridge fairly quick on that. Okay. So saying that, I got the bridge, right? I can expand the view and just go ahead with the bridge itself, right? Now, the trick is, how do we go and approach a slab? And there are different ways to do it, right? So one of the ways, the one that I mostly use myself, is to say, okay, let's do an approach slab to the end, right? And one way to do it is just basically say, look, this is the bridge, my deck here, right? The one that I have, it's an analytical deck, right? So this is the one that is going to be transferred to LibreBridge Concrete, right? So, but then I need to create the approach slab. It's basically another deck, right? So what we do is I would say, okay, I need to place a new support line to create that deck. So I will go parallel to that support, right? And then I just specify the distance, right? So we can specify a distance or not. We could change it to, and then just say, well, okay, let's do it here, right? And that's it. So I got one, right? So from here, I will then say, okay, I need to place a deck. Like we know, we place deck and just specify slab with constraints, you know, the template that we can use following the slab, right? And the trick here is to say, okay, this is not going to be an analytical deck, so that it will not be considered to be sent to lib for analysis purposes. If you are just, you know, modeling, well, just leave it as it is, right? So if you don't care transferring to analysis, it's okay, but then here, so then just say, this goes here, right? And through here. No constraints, just do exactly the same as the template, and you have your new approach slab, quote unquote, deck, just for this, right? So we can as well zoom in here and then just one more time, right? So that will be that, right? So the approach slab is already done right here, right? So now if I go right here, you would see that it's going through the support completely. So let me show now in this transparent view so you can see it a little bit better. Right? But now, as we think of this, right? So this approaches lab, it's been on top of the abutment, right? So what we need to fix then is the abutment itself to go under this, right? So what we have on the abutment side is to generate two options, right? So we included now in since 10.09 release, I'm using 10.09 in this case, right? We say conform back wall to the deck top, right? So this actually what it does, it goes, if I put it to false, it takes the options on the template itself and uses the length or the height of that back wall, right? But still, I'm not going to basically go to here and edit the template to accommodate exactly to that above, right? So certainly I can do that, right? So just go to the template. That's what I'm talking about. Go to the template here and start playing with these dimensions on the cap, right? To set up these options, right? And try to figure it out what is exactly the thickness of that slab to place it here. So no, what we do is still we just go and say from all the way up. So that's what it did with the wizard automatically, right? Encroaches to the actual deck, but then I can go and say right here, back wall vertical offset from the deck top. So if I know that, like for example, my approach slab is 8 inches, right? So then I can say that I need to subtract that offset is in feet, for example, 0.66, right? Done. So, oh, sorry, negative 0.66, right? So, and negative, negative 0.66. And then it's just, oh, it's a little bit. So just to exaggerate, like, let's put it like, 1.5 feet below, right? So then you can see that's what it's doing, right? So you can do that too, right? So this is one of the approaches to do this slab, right? So just back wall offset to this. Right? Now, right here, there is a question that comes to is that, is there a way to add a corbel to the template? Well, we have in some of the templates too, right? If we go here, right? If I go to show you the library, Brian, there's ones that we just implemented some of the corbels here that are part of the offsets and stuff, right? Let's see, one of the Virginia ones was that. Like that, see? Oh, that's on the front, that's also on the back. But then usually what it does is we put it on a parametric cell because one thing is to put a notch there on that, but the best way is to do it in that case is a parametric cell, right? So then on that one, then you will need to do a parametric cell and feed it to that, right? Now, that's one. Now, then it's on here, your question about the approach slab. Yeah, it's 13 inches at the edge and then along to the approach slab. So basically that approach slab, it changes, right? The thickness changes along the length of the slab, right? So, well, yeah, remember that on the deck itself, I mean, this is treated as another deck, right? Is that what you can do is to go here and on the deck template, right? On the deck template itself, what you can do is by distance, by station, right? Let's see when the template shows up right here, right? So you will need to create another one here and then you say, well, let's select that one. And then when you edit that template, right? So what you can do, let me just show it to you here. When you go to the libraries, you may want to create another template here. And so the place template, I'm sorry. So here, right? So select to edit. You can apply variations to the template, right? So you can just select the edit right here and show up in the dialog box. So you can apply it like by distance, right? So changing thicknesses, oh, it's not variable. So like, for example, here, check here, you can apply variable constraints, my bad. Here, on that variable constraints, if this is active on the deck itself, right? So thickness, for example. So when we define it, it was able to do it. So you can go by thickness, by the support line on that deck, you can add it and say, okay, I need, this is for that station to that station. Let me increase the deck to, 13 inches, right? And then for the next part of the support line, right? So maybe for one station, 142 to like another distance, right? So you could just say, what's that, 15, 10 feet, for example, right? So then here it will be 13 inches, right? So it will be what? 1.08. So that thickness is going to be minus 1.08 all the way through. See how it's changing? So, and then here, 1.0833, right? So here, it will be thickened, and then on the rest, it will be 8 inches or 6 inches, whatever you need to do, right? So it will be 10 inches onto that, the rest of the stuff, right? So it will be 10. And then you 0.83. So that's it. So it's 13 inches here, 10 inches here for the first 10 feet, right? Or maybe 15, right? So then when you change it and apply it, right? So we just hit OK. And then your deck will be thickened, right? And then here, well, you got to adjust it, that offset now, here, and say this is minus 1.08, right? That's 13 inches. So then that's it. So you will have that approach slab into tools, right? So that's that. So what else? Car with the several questions coming. With the top of the back wall conform to the beach that crowns in the middle. It could be because here, if you have some options in what's it called elevation constraints, right? So this is one parallel to deck, top slope, right? And then the bottom slope too. So you can make a crown, or usually we try to do level on this too, but if you in super elevation, it's kind of a little tricky too. But again, some of these variations could also be handled there. Yeah. Then Zachary too. Yes, this is not an analytical deck. You're right. Right. When we apply it here, it's non-analytical for sure. Right. So then here's false. Right. So right here. So yeah, it's not corrected. There is no loading to be added into that abutment. So you want to add it or account it for it. Yeah, you have to do it manually in LEAP or LeapBridge Concrete. It doesn't account for that. If you use a parametric cell for the abutment, can you make the top of the back wall follow the bottom of the approach slab vertically? The approach slab vertically. Boy, you will have to enter the dimensions, right? It's not like, depending on the variables that we assign, there is no way to just conform it like that. So you can, but it has to be, I would say, quote unquote, a manual process, because you got to enter the number. It's not something that we do like we do it here. right? So with the variables and the setup right there, right? This is not like that. Now, this is one approach, right? This is one approach. Yep, Steve, you're right. Another one is, yeah, generative components too, a little bit more advanced, but yeah. And then, on the abundance in general, what I can say is that when the abundance get complex, right, and it's a DOT standard, what we're doing for the DOTs is we're creating these parametric cells. We are creating, in some of them, in some of the cases, generative components. Like in Texas, for example, Texas is not using generative components. The abundance are complex, but we can do it with functional components. So with Texas, we're creating functional components for them or parametric cells, right? On the other hand, for New Jersey, there's kind of a unique scenario. So then the best tool to use is GZ, generative components, and we're doing them for them. So it's going to become part of the standards. The beauty of both approaches, functional components slash parametric cells or generative components, is that it has a lot of variables that basically, unless it's a super unique abutment, you will be able to do it all. Right? We're trying to account for all the cases, different skew angles, thicknesses, pile arrangement, reach shaft, whatever you want to apply, we can do it. Right? But so far, with both of them, it's hard to tie it up to read the slope of the deck, for example. Right? Or even we improve it, the functional components a little bit more, but then it's like before we're not reading the ground, for example, so for the piles, the footings. So, okay, so again, this is one approach for the approach slabs, right? So, but then if I take a page from the Florida DOT manual too, what happened if the approach slab actually needs to be on the second part here, right? So they need to accommodate for layer of pavement, right? So it's not something that is reducing thickness, but actually the deck needs to be offset a little bit below to account for maybe an inch and a half of uh, of asphalt. So certainly the approach of just adding one support line will not work because we cannot offset the deck. A single deck can change in thickness, but it cannot be offsetted from the alignment. So what we do, and I can show it here on the other one, right? It's, well, instead of creating one deck for the approach slab, right? Actually, we create two decks. So if we go back to top view again, right here. So what we do is we just create here two more support lines. So we create one parallel here if you want, right? Maybe easier. One here, that would be one deck, right? And then I pick another one right here. So that would be the other deck, right? And then when I build it deck by deck. Again, the same approach, not analytical uh, on that. But then this first one, for example, this will be pure concrete, right? So we'll go all the way to the top. So that will be the first deck. But then when I build the second deck, right, I can say, okay, so use vertical offset. So it will be, for example, an inch and a half. That is 0.12. So the next deck is going to be minus 0.25 vertical offset. So it will read the profile and go below an inch and a half. And that's it, right? So if we switch it around, you can see that little difference there. So that will accommodate for that maybe layer of asphalt there. Right? And then Zachary too, a sleeper slab, say 5 feet by 11, by 11, no, 1 inch thick, centered below the end of the approach slab. Well, yeah. I mean, here you can do a deck on top of the deck if you want, or below the deck too, just accounting for the dimensions. Like, for example, now, if you really want to model that inch and a half of asphalt, even show it with different materials. So, well, I will build another deck on top of this, right? And just call it not analytical, and maybe to that assign a different material to it. So when I render it, it will show black, right, as asphalt. So yeah, you can build these decks on top of each other. The trick is, as I said, make it not analytical, right? And if we're talking about these decks, you can make a sidewalk as a deck too. Some people do it as barrier, but then a sidewalk would also be a small deck on top of the bigger deck, right? And then you can use the horizontal, you're right, Zachary, the horizontal and vertical offsets to play with that dimensions, right? So that will be that approach. Since it's accounted for quantities, right? So when you issue the reports, you will see the concrete material of these decks, and we'll just give you quantities too, right? So that will be that approach. To me, that's the easiest approach to do approach slabs like that, right? So now another one that people as well are using, right? So delete this. It's maybe a little bit more complicated to me, but then on the other hand, they just don't get into these, what can I say, uh, complexities of analytical, non-analytical deck. And I tell you the truth, before we didn't have it even on previous versions. So what they do is they actually create another bridge, right? So these support lines, right, that I have, they are part of this big bridge, right? So let me just delete it. So what they do is, you say, well, this is the station, right? 114 plus 92. So what they do is they just create another bridge. So a brand new bridge that maybe has one or two spans, using the same alignment, right? Same type of bridge, or maybe not even precast. They just go, it's a reinforced slab bridge, right? And then just time, that's a new bridge, right? Show it better. Create the name, right? Maybe slab one, the reinforced slab bridge, and then just select the alignment, right? And they just place the support lines as they are. So we will go multi-support. So it will be a support of two, right? Skew angle 0 and all of that. And then we just say it's one here, and the other one is right here. So the same one. I just to illustrate the concept, you can adjust the stations to match exactly the previous bridge, and then that will be your new bridge, and you can treat it as it is, right? And it's going to be a new deck and everything else. And then they don't call it bridge. Now we just call it approach slab, right? But in the case, it's just part of the other bridge. And then you have it. You can play with the same constraints and all of that. It's just treated as a different bridge. In your Explorer, it will show as another bridge, and then they do the same on the other side. So then you have three bridges for having one bridge, something like that, right? So, well, yeah, is any advantage? Steve, I think it's up to you, right? Tell you the truth, it's just a matter of preference, right? Because they don't deal with analytical, not analytical decks. The one that I showed you before, to me, it's more practical because it keeps everything unite. Here, I have to basically, match the station, right? So I can just have to go to the modify and then just type exactly the station that I want, right? What was that before? 114 plus 92 point something. So I need to match it perfectly, right? and do that. And then, but then when I selecting, I'm not line you select for web page, right? So yes, that I don't see that much of an advantage. I think before the people got used to that because we didn't have the option to separate the deck as analytical or non-analytical. And when you send to leave, they were just sending three decks to analyze and one hanging, so no good. Right now, you want to be more complicated. Some people even created units for approaches slabs. That also can be done, right? So you can create a different unit for your bridge, right? So if I delete these here, so they can say add unit. So, oh, I in the same bridge, but now a different unit that I added at the start of the bridge. So now you got one bridge, right? And another unit to it. And then place again another support line parallel to it. See, now you get confused which one to select, and now it's another unit. So you want to handle that like that? Oh, certainly can be done, but uh, and then you're right, right? So yeah, why? Why? What's the difference? You have another unit, another element to define, and then one bridge instead of three. So again, it's a matter of preference. I think, at least to me, the first one stands. Just make it a non-analytical deck and play with that. And the beauty of that too is that when you move the supports, the approaches lab move to it because it's just part of the same bridge. You got just more supports, right? So this will be, at least to me, the best option to do, right? I know there are more options. You mentioned on the chat here that the Corbels and stuff. So I think that's what we're trying to create an approaches lab tool here, OpenBridge, but it didn't make it for development because people were actually more or less satisfied with what we got here, right? So any more questions? I mean, I'm telling you, that was a short and sweet session on that, right? Is there a way to create a paving notch on the abutment that conforms to the top of the deck? Let me double check that. Is there a way to create a paving notch on the abutment that conforms to the top of the deck? Something else. Level, yes, it remain level. You're right. Depth approach slab would vary from crown to edge. Yep. Yeah, it's that on that. Maybe you need to do a parametric cell for that, right? All these special variations and stuff that you want to do, like a paving notch there, right? So I think, well, the paving notch, you can do it. That's what I did on the previous example, right? I created a separate deck and then basically do a vertical offset on the deck, and that confirms, right? And it's not an horizontal offset, it will be a vertical offset. So that's what it is. Right? And it will match the crown of that. Okay. So any more questions on that? Again, this I told you this is going to be a short and sweet one. Then I think the first one stands, at least to me, that the approaches lab will be done with a separate deck using just placing an extra support line or two support lines if you want to do this uh, allocation for the asphalt surface, right? That's what, for example, that one that I showed you, that's what Florida the DOT shows in their training man, right? Create two separate decks for the approaches lab because one needs to be offsetted from the profile, right? And then adjust it now, Denison as well, with the thickness as well. You could do it along the line and use the offset on the back wall to accommodate for that thickness. All right, so any more questions? So that's all there is for today. As I said, I mean, it's a short concept, but I hope it's going to be useful to you. How to account for the corbel on the abutment back wall to support the approaches slab. Yep, I think I showed it to you already, or to everybody. We can show it again too, right here. When you go to the abutment here, right? So if I select it, right? That to accommodate that thickness, you can do right here on the abutment itself, right? You can just apply a vertical offset on the back wall, right? So it will just apply it to the top. It goes all the way to the top of the main deck. And then you say, okay, I need to accommodate for the thickness of the approach slab that is cut. So just let me exaggerate. See if I put -3 feet. So it will go from the top. It will just go down to whatever thickness is your approach slab, right? So you have to account. You have to enter that distance. So you need to know again what is that thickness, and then it will just match it perfect. Right? Some people do corbels here, right? But then that's we can do. Also, a general question. You cannot apply concrete end diaphragms to a steel bridge. No. Actually, we did it backwards. We can now allow steel cross frames to eye girder bridges, but not concrete ones. Concrete end diaphragms to a steel bridge. No, not. Yeah, we did it backwards. This is where they were requested, but here no, we cannot do concrete on that. Right? Any other question? Even a general question, guys? Actually, at 2 o'clock, we're doing a coffee corner. That was our former SIG meetings in which we're going to present the latest updates or enhancements that we have done in OpenBridge Designer 10.10, the version, the latest one, right? For approach slab that has a smaller width than the end bend, is there a way to have two different elevations for a backward? Outside the approach slab will be the same as the top of the wings, and the remainder of the back wall will match the bottom of the approach slab. No, the back wall goes just following either the slope of the deck or just going up and down, as I said, in a vertical manner, right? So if you want to accommodate for different heights stuff, so then you got to do a parametric cell. Smaller width than the end bend. For the approach slab, you can control the smaller width by the deck constraints, right? You can apply different widths to that, right? But then still, it will follow that in two ends. Outside the approach slab will be the same as the top of the wings. The remainder of the back wall will match the bottom of the approach slab. Yeah, will be a matter to play with the constraints and do it like that. But then, yeah. And also remember, if this is a case like that, like Brian is expressing here, I would say that, you know, if a parametric cell is maybe too much, right? Remember that. And this is something that you really want to achieve, just maybe for that particular project. As I said, if a parametric cell is too much, maybe what you can do is to just place it the best you can with the automated tools, right? And then after that, you can just, can I say, modify with MicroStation, right? Because remember, these are all solid elements. So you can modify with MicroStation on that. But then, well, as you modify it, you will lose the parametrization. But if it's something that you need to achieve maybe by the end of the submittal, then you may want to consider that. Anything could be modified with MicroStation after the fact. It's just a matter of using the modeling tools here, the workflow, and apply these modified solids features and stuff that you can do. Right? So any other question? I think we can just cut it from here. Is there a link available to join the 2 p.m. session? Yes, there's. You can go to the SIG meetings coffee corner and you have to register for that. Right? So let me post the link on the chat. I think constant preview reports. Yeah, I think this will do it. It's called the audience console. Right? So you go to this link. You can just register for the session and then just connect. Well, what other improvements? It's just the ability to add corbels, different dimensions. We know what we show you different tools to do it, right? But then some DOTs are asked for very specific stuff on approach slabs. So far, this is solving the case, but they were planning to do some new stuff, right? So that's that. But it is supposed to be coming on this release. We just prioritize it for maybe a next one. But then so far, the tools that we have done is satisfying the needs of the DOT. So I think we'll stay as it is. I mean, I haven't heard any plans to develop it more, right? Unless it's something standard or something that needs to be done by, for example, accommodating departments. All right. So, okay, guys. So that's it. Thank you so much for attending the session. And well, we see you in 2 weeks for the next session of Ask Alex. I think we're planning to, if it's okay with you, all of you guys, we're planning to show Steve Willoughby. We're planning to show some stage construction on a PennDOT project. So we're going to show you how he dealt with that in that particular case. Right? And other than that, again, thank you so much for attending and see you online pretty soon. Thank you again. Bye-bye.